Thank you so much for having me here. This is really exciting. It's nice to see these kinds of professional development opportunities geared specifically towards women in science. It's really inspiring to see both that there are people here in attendance and that there are resources put forth to support them. So usually I start out with my talk by saying, why does it matter that there aren't enough women in STEM? I feel like I don't need to talk about that yet here. I feel like you get that it's important that women are in science fields. It's not just about representation, it's about women making more money so that they are not at 77 cents on every dollar that men are making. So women are underrepresented in some fields of STEM, as you know. In some areas, there's a great deal of parity. That's great. But those fields that seem to require more intensive math, computer science, and engineering, those kinds of fields are problem areas. There's areas where women aren't represented. And so much of my research on gender and STEM is focused specifically on math. So before I get into that, I want to offer a short disclaimer. There are lots of factors I think are responsible for why we have an underrepresentation of women in some STEM fields. I'm not going to talk about all of them because I think I only have less than an hour. Some of those things people talk about, I want to briefly point them out. Yes, there are concerns that women have children and take time off or maybe are less productive in certain points, particularly when they're junior faculty. I understand that very well. I have 2 small children myself. There's good evidence of sex discrimination in terms of hiring, in salary. This is a controversial point, which surprises me. There are certainly arguments made that there is no bias or there is no discrimination. That's a conversation for a separate time. And then there's also sex bias that comes from teachers. And kids are exposed to that from an early age. But that's not where I'm going. Frequently, people talk about the underrepresentation of women in STEM as being rooted in poor abilities, that it's that women and girls just aren't very good at math, that the reason they're not pursuing these fields is because they can't. As a rule, in most areas of psychology, men and women are far more similar than they are different. Their distributions overlap a great deal, and the differences are very small. And so some of us talk about what we call the gender similarities hypothesis, this rule that basically in most things, not all, but in most psychological constructs, gender similarities are the rule. This is absolutely the case in math achievement, whether you're looking at NAEP data from international assessments such as TIMSS and PISA, or state assessments from No Child Left Behind. These are all showing that boys and girls are equivalent in their math abilities. Done. Does that matter? Yeah, it matters that they're similar, but what else could be at issue in terms of achievement? One concern is spatial abilities, particularly mental rotation, right? The ability to imagine an object in space and how it rotates and picture it in different orientations is important in math. It's also important in things like engineering, dentistry, which always surprises me because I don't think of it as being like engineering, but then I think about small spaces and working with mirrors and sharp objects in people's mouths and spatial abilities. They're important. Girls and boys are differing at these in infancy, and that's alarming because we need these spatial skills. We can train spatial skills and spatial abilities. We can improve them in women. Can we eliminate the gender gap entirely? We haven't been able to yet, as I understand it. But playing Tetris is good for your spatial skills, and it's fun. Those gender gaps in spatial abilities seem to partially explain some of the gaps that we see in STEM achievement. So we can't ignore those, but we know it's not math abilities exactly. I know. We hear about, well, but maybe it's math abilities in really high-level math. Maybe that's where we see the gender differences in achievement. So this greater male variability hypothesis has been around for like ever. And the argument is simply that there are more males in the tails of the distribution in math abilities. So if you look at the top 1% of the distribution in math achievement, you find that there are 2 men for every woman. And that's nothing to sneeze at. That's a real gender difference that can have pretty serious implications. But 2 things to think about. One, this isn't universal. In some cultures, you find that there is no greater male variability. And in other cultures, there is some. So we understand that it's plastic, that there are cultural forces that are shaping how variable men are. So we can't say, oh, it's just that their brains are different, which is very convenient. Moreover, even if this was really all, like the full story, it wouldn't explain why so few women are in those STEM fields, because it would suggest that we'd have actually a lot more women, right? We don't see 2 men for every woman in computer science. Not even close. So that's not the full story either. Increasingly, researchers are saying, well, maybe if it's not achievement, maybe it's attitudes. Maybe it's that, well, girls, they can do the math, but they don't want to. They don't want to keep taking math classes. They don't want to major in disciplines that require a lot of math. Maybe it's just not what's interesting to them. Maybe they think that it's not worth their while. Maybe it's not a good investment. So increasingly, folks are saying, look, it's not about achievement. It's about attitudes. There are a number of theories that we have in psychology that would talk about why attitudes might be important. Namely, we can start with self-efficacy theory, right? I'm not going to pursue any activity unless I think I can do it. If I have a lot of self-efficacy and I feel like, yeah, I'm good at this and I can be successful in it, then I'll pursue it. Another theoretical approach, which has received a lot of attention and empirical support, comes from Jackie Eccles at Michigan, and her approach, or her model, is called the expectancy value theory. And what she says is our choices about academic pursuits and careers are most directly shaped by 2 factors: our expectations of success, i.e., I choose a pursuit or make a choice, an academic choice or an educational choice, because I think I'll be successful. Or I don't make that choice because I think, it's not going to work out. The other most direct force comes from value. Do we value it? Do we think that that choice is good? And value can be things like, I really like math. Math is fun. It can also be, I need to take that next level of math course because it's required for my major. It can be all kinds of things, but it has value. These 2 things, our expectations and our values of math, are shaped by our self-concept, that is our perception of, am I good at this, right? So if I think I'm good at math, then taking that next math course seems probably like something I'll be successful at. So I would have a high expectation of success. If I think I'm really good at math, it can be a valuable experience for me to take the course because it's an opportunity for me to be successful and feel good about being successful, right? And we value those kinds of experiences. But all of this is happening within a cultural milieu, right? The way that we think about our own abilities is going to be shaped by our peers, our teachers, our parents, the media. All kinds of these socializing forces are going to shape our perceptions of our own abilities. It might be that I've grown up hearing this stereotype that girls can't do math, and I'm a girl, thus, right, I can't do math. So in that context, this is where our attitudes are emerging and where they're developing. If that's the case, how do we explain the gender differences in attitudes? I'm going to present some findings from 3 studies on variability in gender differences in math attitudes and achievement. The first one focuses on cross-national variability. This is from a meta-analysis of the TIMSS and PISA data from 2003. The second one focuses on a longitudinal study with Philadelphia high school students, who an ethnically diverse sample of Philadelphia high school students. And this one examines ethnic variability in gender differences. And then the third one focuses on the single-sex schooling debate, just in case there wasn't enough controversy. So let's start with the cross-national study. As I said, these data come from 2 international math assessments. Many of you are probably quite familiar with these. We used the 2003 waves of data because that was what was available when we were analyzing the data. Now they seem really old. Achievement as well as attitudes in a number of different domains, as well as a composite achievement scale. PISA is similar, although the test, some would argue, is a little bit more challenging. The sample is also a little bit different in terms of more developed nations, but they're both major international assessments that combined, we get about 69 countries and 500,000 kids who are either 8th grade or 15 years of age, so about the same sort of window in adolescence. In that one, we have achievement as well as attitudes and affect. So we used meta-analysis to analyze these data. And it's not a traditional meta-analysis in the sense of we didn't go out and collect all these different studies, but we treat each country as a study, essentially. And the first goal with this project is to estimate how large gender differences are in math achievement, attitudes, and affect. We use Cohen's d as our effect size, which is a very simple thing to compute even for us non-math people. Just the mean difference from males from females divided by the pooled standard deviation. I bring this up just as point of reference whenever I present an effect size, a d. I will always follow this convention. So a positive effect size indicates that men or males are scoring higher, and a negative one means that females are scoring higher. The conventions that we typically use for interpreting those effect sizes, a small one is about 0.2, medium is 0.5, a large one is larger than 0.8. So they're just differences between the means in terms of standard deviations. So across those 69 nations, if we look just at math achievement, we find that the gender difference is, not surprisingly, quite negligible. Across all those different measures of math achievement, whether it's geometry or data analysis, measurement, the gender difference ranges from negative 0.11 to positive 0.15. They're pretty darn small. That's what we expected to find. In terms of attitudes, the differences look pretty different. These are ranging from negative 0.28 to positive 0.33. So what does that mean? It means that in things like math anxiety, women were scoring higher, right? So a more negative attitude or affect. In things like extrinsic motivation, so feeling like you should do math for some extrinsic reason, like it'll help you get a job. Intrinsic motivation. I like math because it's fun, it's interesting. Self-concept and self-efficacy, feeling like you're pretty good at math. These are the kinds of attitudinal variables that we have in those studies, and consistently showing that gender differences are small, but always showing that males have more positive attitudes about math. But there's variability from nation to nation. These are very nice normal distributions, and in some countries, the gender differences are large, and in some, they're zero. Some cases they're positive, some cases they're negative. There is that variability, and the next thing we need to do is say, well, what explains that variability? We can't go about conducting experiments to figure out which cultural variables might shape math attitudes, but I can do these kinds of analyses to start to get a sense of, well, what kinds of variables might be moderating that gender difference? Maybe that gives us insight into some of the causes. So we work from the gender stratification hypothesis, which simply says that gender differences in in math ability or achievement and attitudes are rooted in cultural variations in opportunity structures for girls and women. What that means is that the personal is political. If I look around my community as a young girl and I see, wow, women are scientists, women become doctors, women become engineers, I think I can be anything. If I look around in my community as a young girl and I say, I'm going to be a mom, I'm going to be a good mom. Moms are great. But that's what I'm going to do. I'm not going to have a career. That's what boys do. I'm going to think very differently about my education if I think it's not really going anywhere, right? I'm going to have much more motivation to perform and achieve well in my classes if I think I need this. This is valuable. This is useful. And so we think about these sorts of visible role models or the representation of women in political or other public arenas, right? Just this perception that women have opportunities. And this is what we would think of as gender equity, looking around your community and saying women and men are equal. Women and men have the same opportunities. They can do anything. And if I perceive that in my community, I have much higher expectations for myself and a broader range of possibilities for myself. So we predicted that in nations from these samples where there was less or where there was greater gender equity, that the gender gaps would actually not just be smaller, but that they would favor men less. So we predicted that, say, in the countries where women were represented better in STEM fields or in higher education, where they were going to university at the same rates that men were, that in those communities we would see negligible gender differences or even negative gender differences in achievement, and that the gender differences in math attitudes would either be closer to zero or even negative. Right? So, what does gender equity look like? This is sort of an amorphous concept. If you stop to think about, well, if I wanted to measure what it looks like in a country to be treating men and women equally, to say this is an equitable or fair gender egalitarian country, what would it look like? There are a lot of measures of this. The United Nations Development Program produces a few composite measures of these that were actually developed by a Nobel laureate some 20, 30 years ago almost. We took some of those composite measures, but we were much more interested in what we would call domain-specific indicators. So things like indicators that spoke specifically to educational domains of gender equity or political domains of gender equity, economic domains, those kinds of things that might give us insight into specific mechanisms. So the two types of things that were most useful and I think are most germane to the question refer to women's representation in STEM jobs. So what's the proportion of STEM jobs that are held by women in a country? And I think that speaks to the idea of visible role models, as well as gender ratios in primary, secondary, and tertiary education. So are women going to university? And this is measured in a really nice way. They say, okay, well, of the girls of a specific age group, when they're eligible to attend school, what percentage of them do? And they take the ratio of that to the same percentage or proportion for men or boys. So what we found is that these kinds of measures of gender equity explain up to 37% of the variance in math attitudes and achievement. Not always, and in some cases, not at all. But the majority of them they did. And they all pointed in this direction that when you have, say, more women or that more gender equitable enrollments in a university, that the gender gap in math is smaller. So we can compare specific nations. By and large, you know, the effects are pretty reliable with a number of these, and I think it's important to think about, well, again, what are the mechanisms that might be operating here? this is enrollments in tertiary education. This is women in research jobs or STEM fields. That one's pretty powerful. That, say, with regards to self-concept, when you see that women are working in science, that girls are having attitudes about math that are, and feeling better about their math abilities, less different from males, that there's more equity there. Part of the UN Millennium Goals are that gender equity in multiple domains become a reality. And part of that is gender equity in education. It's a basic human right, and yet there are still many cultures around the world where girls aren't going to school. They're not going to primary school, secondary school, or they're not going to university because it's not considered valuable, because their education isn't valued in their culture. They are seen as a liability rather than an investment for their families. So let's think about some of the implications for gender equity in terms of these mechanisms. I keep coming back to visible female role models. I think that this is crucial, and I'll talk more about this later. There's more and more evidence showing the importance of role models in terms of giving us a sense that we belong in a field. If I walk into a classroom and I see that not only are all my classmates the opposite gender, but so is my instructor, I get a pretty clear message that I'm the oddball. I don't fit in. And it takes a great deal of motivation and interest in that field to stick with it despite those signs. I think we also need to think about how students perceive those sorts of situations when they don't see a lot of women in those fields. I was telling this story earlier to some undergrads here that my daughter has her science fair today, and she's in first grade, and we were taking in her trifold poster last week, and I'm asking her all the kinds of goofy questions that psychologists ask their kids. We really do. And I said to her, some people think that girls aren't very good at science, or that they can't do science. What do you think of that? And she just looked at me like, that's just strange, Mama. You're a scientist, and you're a girl. And I thought, yeah, exactly. You see that. And it's not going to cross your mind. You're never going to think, I can't do science just because I'm a girl. You see that. Those kinds of messages are important. Granted, I probably harp on these things a lot with my kids. I'll admit that. But it's still important. We don't want our daughters or our sons growing up thinking that they are limited in their opportunities simply by their gender. And so we have to be really proactive in making it clear to them that there are those role models. So what are students seeing? Do they perceive that there's equity? Do they think that their community values their achievement? Do they think that their community and their families value their education and say, yes, of course you should go to school. Yes, of course you should have a career. And that doesn't preclude you from having a family. That doesn't preclude you from being a successful woman in other ways. So I'm talking about culture, and culture across nations, but we have a great deal of cultural variability here within the United States as well, across ethnic groups. In general, the research on gender tends to be very distinct from the research on ethnicity, in psychology anyway. I don't know if it's that way in other disciplines, but there's the researchers who study ethnicity and there's the researchers who study gender, and they tend not to collaborate. Or when they do, they don't think to say, we should look at gender and ethnicity at the same time. We talk about an approach called intersectionality that says, well, the meaning and experience of one cultural or social identity depends in part on the meaning and experience of another identity. So my experience as a woman depends in part on the fact that I'm also white and I'm straight. And those things are going to shape how I experience being a woman in this culture. So given those kinds of perspectives, we thought, well, we really need to understand, do these gender differences in math attitudes that we keep thinking are pretty pervasive. Do we also see them in ethnic minorities, or is this another one of those cases where it's really just about the white kids? In fact, NSF is diligent about producing these statistics about the representation of women and ethnic minorities and underrepresented minorities in STEM fields. And a recent report said 8% of STEM jobs are held by ethnic minority women. Okay, all the more reason we need to be talking about the intersection of gender and ethnicity. Actually, let me back up. So we know something about gender, this intersection in terms of achievement. So, for example, on the NAEP, we know that gender gaps in math achievement are larger or more significant among the white kids and Latin kids. That Black and Asian kids look a little different. That you see more gender similarities there. So we had some reason to believe there might be some variability, if there is, at least in achievement. But we had nothing to go on in terms of attitudes. I mentioned STEM stereotypes briefly before, and I want to come back to them because they're not just about gender. They're also about ethnicity. They're a part of that cultural milieu that I was talking about before with the Eccles model. And we know that they predict our academic attitudes and achievement. When we endorse those kinds of stereotypes and we self-stereotype ourselves, they limit our achievement and they produce more negative attitudes. There's, of course, the process of stereotype threat, whereby simply being aware of your identity as a stereotyped group that can impede your achievement and your performance on a test, possibly by interfering with working memory. So these stereotypes, they're important and they're real. We tend to think about scientists as being white or Asian men, and we don't go beyond that. And unless you're one of those guys, you don't see yourself as a scientist, potentially. We know that even in first grade, kids are thinking this. First grade, they're already thinking, if I'm a girl, I can't be a scientist. So we conducted a longitudinal study with high school students in Philadelphia. We specifically sought out to recruit kids from 4 different ethnic groups. We wanted to equally represent those 4 ethnic groups, have equal numbers of males and females from each group. We recruited high school sophomores from urban public neighborhood high schools. What that means is these were schools in Center City, Philadelphia. They were neighborhood schools, not magnet schools. They weren't charter schools. They weren't selective in their admissions process. They were the school you went to if you lived in a certain neighborhood. We chose schools that were diverse. We didn't have a school that had all the Asian kids in it and a school with all the black kids and a school with the white kids. We chose schools that had at least 12% of each ethnic group in them. So they were specifically selected for being diverse but non-selective neighborhood schools, public schools. So we had equal representation, roughly, of African American, white, Latino, and Asian American kids. We had about 360. We had 359 parents also participating. I'm not talking about parent data today, but we recruited them their sophomore year and then followed them for 2 more years after that. The sample is pretty low SES. Parents had, about half of the parents had either a high school diploma or less. 72% of them were native English speakers, the kids, and 81% were U.S. born. This is actually slightly less than the national statistics for number of native born kids, but it's a nice attribute of our sample that it's really diverse and represents the city really well. We assessed a lot of things, but the things I'm going to talk about today were their math attitudes, and they're informed by the Eccles model. So we assess self-concept, that is, I'm good at math, or if I were to rank all the kids in my math class from best to worst, this is where I would rank myself. Expectations for success. I think I will do well in math next year, or I think I will earn a good grade in math this year. If I were to pursue a career that required math, I would be successful. And then value. It's important to me that I do well in math. I like math. So those are our attitudinal variables. We also assessed achievement via end-of-year grades. And we adjusted these based on whether kids were in advanced or AP math classes versus regular and remedial. So first, let's look at the gender differences. We saw similarities in achievement, no significant difference in terms of end-of-year grades, which is about what we expected. There's a lot of data showing that girls actually get better grades than boys do from kindergarten through college graduation, but we didn't find that. In terms of attitudes, we found some significant effects here, with boys having more positive attitudes in terms of math self-concept and math expectations. So, small effect sizes, but about a third of a standard deviation. But then we looked at ethnic group differences. We found that the Asian American youth outperformed significantly every other ethnic group, but that the African American youth reported greater math value than white youth by half a standard deviation, which is pretty impressive. It's interesting, when these data were published, we put out a press release talking about how important it is to think about gender and ethnicity simultaneously, and what our findings were, and how we had this great sample that was ethnically diverse, and kids who aren't normally represented in psychological research. And nearly every newspaper or magazine or blog post that came out about it focused on one thing, actually two things: that girls and boys did just as well in math, and that Asian American kids are outperforming everybody else. They didn't want to talk about anything else. That was what the press wanted to focus on. No matter how many times I harped on the phone or in our interviews, that's what they cared about. And that's what people seem to want to keep hearing. Something to think about. In terms of that intersection, we tended to find a great deal of variability, pretty small, non-significant interactions. Our sample was, I'd say, medium-sized. It felt a lot larger than it was during the data collection process, but I think we found a fair amount of variability, generally pointing to larger gender differences among the Asian American and Latino kids, and smallest gender differences in attitudes tended to be among the African American kids. To some extent, that was what we expected. We didn't expect huge effects, but we did expect to see some trend like that. But one of the things that really came out of these data, and while we're talking to parents on the phone and entering data from the surveys, we kept thinking, wow, there are some really serious problems in the public education system. We have a lot of families who are skeptical of participating in research because they feel like they maybe are being judged or evaluated. We had parents who couldn't speak English and couldn't participate in the survey, and their kids were calling us saying, hey, can I participate in the study without my parents? They don't speak English. Or kids telling us on their surveys, Mom and Dad don't help me with my math homework because they don't know how to do it, or they can't read, they can't speak English. That there are pretty serious problems that some of these kids are facing in the urban public schools, which has been dealt with. I think that, a lot of folks know this is a real problem. Urban schools are struggling. We collected these data in Philadelphia, and in the school district of Philadelphia, between waves 2 and 3 of our study, they laid off half the staff in the whole school district. And the year following, after the third wave of data collection, they closed dozens of schools. And last year, dozens more. Right? They're struggling. And they're not the only urban school district that's struggling in this way. They're struggling to meet the needs of kids who are coming from households where they just don't have enough resources. One of the approaches to deal with this has been the charter school movement. Another approach that we're seeing a fair amount of, particularly with these samples, is single-sex schools. People saying, well, maybe boys and girls need to be educated in different spaces because they have different learning styles. No such thing. Makes me crazy. It's like saying somebody just can't do math, right? It's not a thing. It's a mindset. It's not a thing. Or maybe they need to be separated because they've got all those hormones. They're a problem. So let me give you a little background on single-sex schooling. Title IX made it prohibited single-sex schooling in public schools, sort of. Basically, it said if you're going to have a single-sex school, you have to have the exact same opportunity available to the other gender. So for the most part, after Title IX, we stopped seeing single-sex schooling in the United States, except in private schools. And then No Child Left Behind, everybody's favorite punching bag. Thanks to some senators, such as Hillary Clinton and Barbara Mikulski and Kay Bailey Hutchinson, all women who were educated in women's schools said, but we need to fund single-sex schooling. We need to make girls' schools an option for public school kids. And so they wrote a provision in here that allowed public money to be spent on single-gender schools. And we have seen an explosion in the number of public single-sex schools since then. And it keeps coming back in these urban school districts to the ethnic minority achievement gap. They can't say, oh, well, we need to educate, ethnic groups in different schools, different ethnic groups in different schools. They can't say that. But they can say, well, but maybe we need to provide young black men with male role models because they don't have these. Not really sure where they're getting that from. And then they need to provide female role models for these young black women without all the sexuality problems that happen when they're in a mixed gender environment. A lot of the claims really are resting on some pretty sexist and racist stereotypes that we have about these groups. Moreover, they're kids coming from communities where there isn't sufficient advocacy often. We're talking about poor communities. They don't have a lot of resources to say, wait a second, I want some data before I say, yeah, my kid's going to go to this school. They just want something better than what they've got, and they're willing to try it. And so we see this proliferation of these single-gender schools, particularly in urban communities, and they're being touted as a remedy for the ethnic minority achievement gap. If you look at narrative reviews of the literature on single-sex education, several conclusions become pretty clear. One, most of them are very mixed in their findings or find no benefits or disadvantages to single-sex schooling. A handful find more positive effects for girls, that is, that girls would have more positive attitudes and gender atypical choices. So girls are more likely to say, yeah, I'll pursue a career in STEM. There are some methodological problems I'll get to in a minute that might be at the root of that. More recently, a meta-analysis of those studies has found that the difference between single-sex and mixed-sex schools in terms of math achievement is close to 0.03. So overall, no benefit to single-gender education is the conclusion of that report. One point I want to make before going on is there's this assumption that if you're separating girls and boys and saying, oh, we're doing this because it's for their own good, that there's, girls and boys might be different and they have different needs in a classroom. Some of the big advocates of single-gender education say things like, you have to speak very quietly in a girls' classroom, and you can't have opportunities for competition, and you have to give them lots of praise and be very warm. Because apparently they're eggs, they're very fragile. They will just break under pressure. But boys, they need lots of activity and competition, and I don't know, I hear that and I think, that just sounds like you're setting girls up. That doesn't sound like a good setup for them. There's plenty of sexism in the single-gender classrooms, too. Just because you separate them and say, I'm trying to help each of them, it doesn't mean there's not sexism there that they're picking up on. And there's real evidence of sexist stereotypes coming from the teachers and the advocates of those systems. So I said before, there's some methodological issues. It's been called pseudoscience. I think part of the biggest issue is that most studies of single-gender education are based on private schools. And so they're high SES samples, right? They look like they're going to be very effective schools because the kids do well. Well, it turns out that typically high SES kids do well, whether they're in single-gender or mixed-gender schools, right? They have a lot of resources. They're going to do okay. So that's part of the issue. There's this selection bias that you also find in single-gender schools in that, for example, private schools in my community in near D.C., if you want your child to go to them, they have to take a standard IQ test first, and that shapes enrollment. So if I have pretty selective admissions processes like that, I become a school that's not terribly comparable to other schools, right? So I have to be careful about trying to generalize from those schools to others. In addition, some schools will kick out kids if they don't meet certain standards. And those standards can be terribly high. It's not simply they're failing. It's you're not good enough. We don't want to keep you in here because you're problematic for our staffs and our recruitment. And so they have this culling process on a regular basis. And I hear parents in D.C. talk about this with their kids, and I think that's terrifying, right? As a parent, that terrifies me, the idea that my kid could just be tossed out if she's only average. So these are problematic studies. We don't know how to go about making generalizations because the samples are so biased. And there's also this problem of they're not randomly assigned, right? You can't prove any sort of causal argument if you don't have random assignment. It's sort of classic research methods. So it turns out that for a time in one country, Korea, they had random assignment to single-gender or mixed-gender schools. It's like one of those super exciting natural experiments that people like me get all jazzed up about. And what they found was no benefits. No benefits of single-gender or mixed-gender schools. And so we still keep going, well, it still doesn't look like there's anything going on there, but we have to keep probing because people keep opening these single-gender schools and we need data. The other major weakness I see with a lot of the single-gender schooling research is that they tend to neglect boys. They're so focused on women. Now, I teach psychology of women. That's my thing. I love that. But it's important that boys and men are doing well, too. And so I don't think we should be ignoring them at the expense of women, in order to help women. We need to be thinking about, well, if we're making girls' schools, are we also making boys' schools? Where do those boys go? And what happens to boys in single-gender schools? And most of this single-gender school research has been based on girls' schools. In addition to these other selection biases, we typically don't have data on Black and Latin youth in these schools. So they're mostly focused on white or high SES kids. And so in our country, that means we're neglecting these kids. And yet, we're seeing the proliferation of single-gender schools focused on those communities, but no data to support their efficacy. So it turns out that in Philly, until very recently, there were two neighborhood schools in the same neighborhood. There was a girls' school called Rhodes, and there was a boys' school, Fitzsimons. And if you lived in a certain geographical boundary, you went to one of those schools. You could request to go elsewhere, but most kids didn't. And you could, if you lived elsewhere, you could request to go there, but few kids did. We recruited from those two schools, as well as from 8 other comparable schools in nearby areas in Philly. We recruited high school juniors. They were 98% black, and that 2% is mixed race. So we have a pretty narrow slice of the population in Philly, but and a fairly homogeneous group, but low SES. These are not generally the neighborhood schools in Philly that are serving these populations are not good schools. These are schools where 20, 30% of the kids are achieving competency on their math and reading assessments. They're not places you want your kids to go. It's where your kids go if you don't have other options. We assessed math attitudes, self-concept, expectations, math value. We also threw in some of the measures from the PISA assessments, such as math anxiety and self-efficacy. To assess achievement, we used their PSSA scores. So the PSSA is the state assessment that's done every year as mandated by No Child Left Behind. So standardized math test scores. With regards to math achievement, we found that in the mixed-sex school, we found gender similarities. Oops, I've switched those. My mistake. Reverse those numbers. Just imagine. Mentally rotate them. Sorry. I've been trying to think of a good math joke for you all, and that's the best I can come up with. So gender similarities in the mixed-sex schools, 0.13, right? There's nothing going on there in terms of math achievement. The mixed-sex schools, the girls and boys are doing essentially just as well as one another. But in the single-sex schools, we find that girls are vastly outperforming boys. In no other area have I ever gotten a D this big. It's really exciting. Something's going on. Why would the girls be outperforming the boys in the single-sex schools so much? Let's keep probing. Let's look at attitudes. The effects of single-sex schools were positive for girls and negative for boys. They echo the same findings we found with achievement, that for girls, single-sex schooling seemed to be really beneficial. But for boys, it was actually harmful. Their attitudes about math were lower in the single-sex school than in the mixed-sex school. The same pattern was found with reading and science. So again, we have to think about everybody, not just girls, not just boys, not just the white kids, not just the kids who are of ethnic minorities or underrepresented groups. We need to think about everybody, and that's what equity is really about. One of the points that I hope is clear is that the gender gaps that we see in achievement and attitudes are very plastic. They are not fixed. They are not rooted in some basic biological difference. They're not about our brains being vastly different. We are far more similar than we are different, but that can change. Our culture can change those things. We can encourage kids to pursue some things and discourage them from pursuing others. We can provide professional development experiences that say, keep going, you're doing great. And that's important. We need to think about ways that we can create more equitable learning opportunities for everybody and reduce not just the gender disparities, but also the ethnic disparities that we see in income. That's part of the reason that those STEM jobs are so important. It's about income. It's about real equity across the whole lifespan. Generally, people don't like being the only one, right? You walk into a classroom, if you're the only person of color, or you're the only woman in a classroom of men, or you're the only man in a classroom of women, you feel self-conscious. You feel like you don't belong. That's a problem, right? If we really want to think about how do we get girls to pursue, say, computer science or engineering, we need to address this issue. If they're not being represented in the classrooms, they need this critical mass, if you will, to start feeling like, okay, yeah, I belong here. It's okay for me to be here. I'm not in the wrong classroom. Role models are critical. Role models help to transmit attitudes. We know that kids who, if you think about elementary schools, who our math teachers are or who our teachers are in elementary schools, they're women, predominantly. Right? If you have an elementary school teacher who is anxious about math and you were a girl, your math achievement will be equal to boys at the beginning of the school year, but poorer than boys at the end of the school year. That teacher, probably not trying to do this, of course, is somehow transmitting that anxiety about math, and it's impairing the girls' abilities and their performance. That's a real problem. Parents do this too, right? Role models can also convey a sense of belonging, to say, I'm like you. I'm your teacher, and you and I have things in common. And that is a sign to you that you belong here, that you fit in. And you can come to me as a mentor. I can be somebody who guides you. Or maybe we can reach a point where you don't need that. You don't need a gender-specific or ethnicity-specific mentor to say, yeah, you can keep going in this field. You fit in here. It might be a point that you don't even question. I think about my own vocational and educational development and how I got to where I am. There's a fair amount of it that's just luck, honestly. And there's a huge part of it that's about mentors, about people saying the right things at the right time, about colleagues saying, you're doing great, and encouraging me to keep going in the face of failure, about teachers saying, hey, maybe you should major in this, or would you like to work on a project with me? Do you want to write a paper on this topic? Any of those things, they're really important. And I'd be lying if I said that I got to where I am totally on my own without the support of those people. I want to point out my gratitude to the National Science Foundation that funded each of those projects that I presented, as well as those awesome mentors and collaborators that I've had, and my many grad students and undergraduate students who have done a great deal.